Okay, so we're looking at the quotient rule now. This is the last rule that you need to be able to use in the Tech 3 exam when we're talking about differential calculus. But it does involve, you are going to need everything else you've learnt before about circular functions, differentiating exponentials, differentiating logs, and so on. Quotient, hopefully you remember, that's when we have a fraction or when we're dividing. So it's when we will have one function divided by a second. And when we notice that we have one function divided by the second, that's when we know to use the quotient rule. So let's have a look at it together now. Okay, so once again, the formula can be written in two different ways, depending which type of notation we're using. If we've got one function divided by another, the formula, as we can see here, we differentiate the first, g dash x, multiply by the second, h of x, minus the derivative of the second, multiplied by the derivative of the first. Now the order is essential in this case. With the product rule, you might recall it didn't matter which order we differentiated in because we had a plus sign in between. Because there is a minus sign in between, this order is essential. The other way that this quotient rule can be written, and is found on the formula sheet, is that if we differentiate where we have one function u divided by the second v, what we do is that we differentiate the numerator, du dx, and that's multiplied by the denominator, minus we differentiate the denominator, and that's multiplied by the numerator, and it is all over the denominator squared. This is on the formula sheet, we just need to be able to apply it. So let's do some examples. Okay, so we want to differentiate each of the following with respect to x. If we are differentiating the first function, so let's use the product rule as it's written on the formula sheet. I'll just write it up the top here again so that we keep this in mind when we're going through this process. Remember, in this case, the order is very important and we need to follow the order given. So we will let u, the numerator, and sorry, just a minute, I've drawn this like it would be the product rule there. What we're doing is that we are having u over v, okay, because it's the quotient rule. So we let u, the numerator, equal 2x plus 3, and v, the denominator, equal 5x minus 2. In this case, it is very important that u is always defined as the numerator, and v is always defined as the denominator. We differentiate each of these with respect to x. The derivative of 2x is 2, the derivative of 3 is 0. Then we differentiate the second, dv dx, derivative of 5x is 5, and derivative of 2 is 0. Okay, so using our formula then, if we differentiate d dx of our function 2x plus 3 over 5x minus 2, what we do is that we have the derivative of the, so again, let's use some colours to explain this more fully. We start with v, 5x minus 2, all of v, so we put it in brackets, is multiplied by du dx, which is found here, multiplied by du dx, and then according to the formula we have to subtract. We substitute in u, and u is found here, all of u, so let's put it in brackets, and all of u has been multiplied by dv dx, and dv dx is found here, and it is all over v squared, the denominator squared. So our v squared, again, our denominator is 5x minus 2, we put it in brackets, all of the denominator squared. We do need to simplify this. Like I've said before, our answers need to be either fully expanded or fully factorised. Let's expand the numerator. That would give us 10x minus 4. Now, if I'm expanding here, negative 2x times 5, that's negative 10x. And then negative times 3 times 5 is negative 15, all over the denominator. There is really no need to expand the denominator. There's a risk of further engagement that we might make a mistake when we expand the denominator, so let's leave it factorised. In the numerator, 10x minus 10x is 0, negative 4 minus 15 is negative 9, all over 5x minus 2 all squared. Okay, let's have a look at the second one, and let's work out this second one again by thinking about step by step rather than defining u and v. Let's think about what happens using the shortcut method. Once again, it is up to you which way you prefer to do this. So, if we are using our shortcut method, what we do is that we start with our numerator, we differentiate the numerator. The derivative of the numerator is 3, and we multiply that by the denominator. And the denominator is square root of 6 minus 2x. We then subtract the derivative of the denominator. Now, to differentiate the denominator, we really need to write this with a power. And hopefully you notice that we need to use the chain rule to differentiate the denominator. So we multiply by the outside function. We multiply by, to differentiate the outside function, we multiply by the power, we subtract 1 from the power, and what is written inside stays the same. Then we multiply by the derivative of the inside function. Derivative of 6 is 0. The derivative of negative 2x is negative 2. So that's the derivative of the denominator. And we multiply this by the numerator, 3x. So if we're noticing what's happened, just think about this carefully for me. You need to be very careful to get this right. We differentiate the numerator, and then we multiply by the denominator. Minus, we differentiate the denominator and multiply by the numerator. And it is all over the denominator squared. The denominator is the square root of 6 minus 2x, and we need to square that. Let's start sorting this out. From here, that was the calculus step, okay? That was the calculus. The next step, the rest of this is algebra. So, 3 square root of 6 minus 2x. We can't really simplify that anymore, so let's leave it like that. Let's now simplify what's going on here. We have a negative just here multiplied by a negative here. It's going to make it positive. We have half multiplied by 2. That can cancel. So we will have 3x in the numerator divided by, because we've got a negative power here, negative a half, we can write that as 6 minus 2x in the denominator. That is all over. If I have the square root squared, it will just give me 6 minus 2x. Now this is not nice. We can't have a fraction within a fraction. So we need to look at the numerator and put the whole numerator over a common denominator, which would be 6 minus 2x. So when we're looking at this, if I want to make this second term here over 6 minus 2x, that means I also need to multiply by 6 minus 2x in the numerator. So what I will get for my numerator here is 3 lots of 6 minus 2x, because if I've got the square root of 6 minus 2x times the square root of 6 minus 2x, this gives me 6 minus 2x plus 3, because that already has our common denominator. And we're dividing that by the denominator of our original fraction here, 6 minus 2x. If we simplify the numerator, I will have 18, expanding here, 18 minus 6x plus 3 over square root of 6 minus 2x. Let's just write that for a second as 6 minus 2x to the power of a half. When we divide by 6 minus 2x, that's the same as multiplying by 1 over 6 minus 2x. And when it's not written, that's to the power of 1. So when we simplify here, in the numerator I have, collecting like terms, 18 plus 3 is 21 minus 6x. In the denominator, I have got this, the base is the same, 6 minus 2x. I'm multiplying, which means I add the powers. And I've got half plus 1. It's a power of 3 over 2. Okay? So when we're thinking about this, we differentiate using the quotient rule. Then we need to use our algebra skills to simplify as much as possible. Okay, for the first one, remember we can either do this using the shortcut, we can use the formula on the formula sheet, or we can use the alternate notation. Either way, we're doing the same thing. If we are using the alternate notation that was given when we started, what happens is that we need to differentiate. To find f dash x, we differentiate the numerator, multiply by the denominator, minus the derivative of the denominator, multiplied by the numerator, and it's all over the denominator squared. However we write it, whatever notation we use, we're doing the same thing. If we're doing that, we need to define our numerator and denominator. So we let g of x equal cos x, and we let h of x, our denominator, equal sine of 3x. We need to differentiate both of these. So to find g dash x, derivative of cos x is negative sine x, and the derivative of h of x, to differentiate, we differentiate the argument first. The derivative of 3x is 3, derivative of sine is cos, and the argument stays the same. So to find f dash x using our formula that was given, we take g dash x, which is negative sine x, and we multiply by h of x, which is sine of 3x, minus, which is from the formula given, h dash x here, 3 cos of 3x, multiplied by g of x here, which is our function here, which is cos of x. That is all over our denominator, which is sine of 3x squared. Remember, when we square circular functions, we write the squared sign just here, in between the trig function and the argument. Now we actually can't simplify this anymore because the arguments are different. We have sine of x and sine of 3x, different arguments, we can't simplify, and that is our final answer. Those of you doing spec, you might consider other ways to simplify it, but in methods it is not needed. Let's go on and have a look at the second one. Let's differentiate this without defining things, but just by thinking about what we need to do step by step. Once again, it's up to you how you approach these questions, but you do need to make sure that you're consistently getting them correct. So, we differentiate the numerator. You should remember that to differentiate log functions, what we do is we take the derivative of the inside function, which is 6, over the function, which is 6x. So we have the derivative of the numerator multiplied by the denominator, which is e to the power of 4x plus 2, minus, that's part of the formula, we differentiate the denominator. The derivative of e to the power of 4x, we differentiate the power, which gives us 4, and then we leave the function as is. Derivative of plus 2 is 0. So the derivative of the denominator we can see here is 4e to the power of 4x. And we multiply that by the numerator. And that is all over the denominator squared. That was the calculus step. The next steps are just algebra. We need to simplify this. We need to get this to look a bit nicer. We can cancel 6 and 6 here. So we can write this as x is in the denominator, e to the 4x plus 2. The rest of the numerator is minus 4e to the 4x log e of 6x. Now it's tricky having fractions in fractions, so let's think, here's our numerator. We want to divide it by the denominator, e to the power of 4x plus 2 squared. Our numerator that we have here, we need a common denominator. The lowest common denominator would be x. We already have an x in the first part here. For the second part, for us to have a denominator of x, we need to multiply this term, this whole term here. We're multiplying it by x over x. The x will give us the denominator. So what we will get is minus 4x e to the 4x log e to the 6x, and we actually can't simplify that term any more than that. When we are dividing by something, that is the same as multiplying by 1 over the actual function itself. If we simplify numerator multiplied by numerator, we get e to the 4x plus 2 minus 4x e to the 4x log e of 6x all over x multiplied by our function here. And that is as nice as this is going to get. I know it doesn't look great, I know it's not that simple, but we actually can't simplify this much more. We could expand the denominator if we wanted to, but there's not really any need. And so that is our final answer. But it is better than the answer we had to start with because we can't have fractions within fractions. Once again, if you have any questions, please make sure that you write these down, make a note of them, and ask me next time you see me.